Welcome, everyone, to the Sustainable Homes Professional live webinar of installing heat recovery ventilation systems. During the next 45 minutes, we'll dig into the details that you'll need to know to select and install effective balanced ventilation systems in a super tight house. I'm Ali Callow Spencer, Training Development Lead for Earth Advantage. I assist Earth Advantage's training programs, curriculum development, and I am here to support participants with inquiries along the way, especially getting their CEs and certificates. Before we begin, we would like to take a moment to thank our partners at Better Built Northwest for generously supporting this training. Here is a screenshot of the Better Built Northwest website where you can find a wide variety of trainings, tools, and resources to support both code and above code building, as well as directories that will help you search by zip code to find an energy irradiator, utility incentive programs, certification programs, and other professionals in your local area. Overall, Better Built Northwest is an excellent resource, and we encourage you to take a look. I'd like to start off by letting people know that this is one of 3 on the level series and is part of Earth Advantage's new Sustainable Homes Professional course, now available online. These recorded live webinars recreate the same in-depth experience as the in-person SHP class, now available from the comfort of your own home. The On the Level series is just one of the many content benefits when enrolling into SHP. We'll talk more about SHP online training at the end of this program, but did want to thank the 50 or so attendees of this webinar who have already signed up for SHP, along with everyone else who is joining us here today. So now to introduce our instructors. Alexander Boetzel comes to us from Greenhammer as their Director of Operations and Sustainability. With over 25 years experience in construction and building science, Alex is a certified passive house consultant and has consulted on multiple living building challenges and dozens of lead passive house, high performance, and green residential projects in the US as well as Europe. Waylon White is the Senior Manager of the Green Building Technical Services at Earth Advantage and has over 20 years of construction experience with a wide variety of building types and a sharp focus on high performance design and construction. At EA, Waylon has been instrumental in refining and developing Earth Advantage's new home, multifamily, and LEED certification program since 2013. And we're lucky to have them both here with us today. So without further ado, Waylon, why don't you take it away?
Well, thanks, Ali. I'm really excited. Today we've got a great presentation here and really excited to have Alex Boetzel with Green Hammer joining us. Today we're going to talk about heat recovery ventilation and different approaches along a good, better, best spectrum. And we're going to talk about some of the field-proven technologies, understand how to implement ventilation and understand the process that it takes to effectively make it work better than just a couple of exhaust fans, because HRVs, when not installed properly, can work basically about as good as just a couple of exhaust fans. So we're going to gain some valuable installation insights and tips with Alex, who has installed, designed, and commissioned dozens of heat recovery ventilation units in Oregon. And we're going to talk a little bit about why, some of the benefits of balanced ventilation as well. So heat recovery ventilation is certainly the optimal ventilation strategy. Oregon Energy Code, Washington Energy Code are requiring balanced ventilation now, and ventilation with heat recovery gives you an opportunity to increase your amount of ventilation over just the minimum amounts required by code, which can increase the health and comfort and indoor air quality of your space. It can provide energy savings, And in a climate where we are in Portland, Oregon, that may not be as important, but in other climates in the US, that's certainly a huge factor as far as bringing in tempered fresh air. And we're going to show how this is a very cost-effective code compliance path, not only currently, but especially in the future, as at least in Oregon, we're going to see probably multiple additional compliance measures required. So here you can see in the 2021 Oregon Residential Code that balanced ventilation is now required in the state of Oregon. And as a list of additional energy efficiency options, energy recovery ventilation is available paired with the house tightness of 3 ACH 50. And so what we see this as, you're already having to meet a lot of the air sealing requirements in the new code. Getting to that 3 ACH 50 is not a huge leap. You're already having to install balanced ventilation. What we're going to show you today is that installing balanced ventilation with heat recovery is also not a huge leap. Here you can see in Washington Energy Code, it's similar as far as giving a credit for having efficient heat recovery ventilation as well as air tightness. And as your air tightness improves, you're able to earn additional credits, getting to that passive house level of 0.6 ACH 50 and a very highly effective HRV and ERV. And we're going to talk about the sensible recovery efficiency and different metrics for HRVs and ERVs here soon. So one of the important things is initially, when designing a system, understanding how much fresh air. So Energy Star, Earth Advantage, the EPS program by the Energy Trust of Oregon, most of the national energy efficiency programs, and including the state of Oregon, are using ASHRAE 622 2010. And the way that you calculate fresh air requirements for a building using this calculation are 1% of the floor area plus the expected number of occupants times 7.5. So 7.5 CFM times the expected number of occupants. So the expected number of occupants is 1 per bedroom plus 2 in the primary bedroom. And so number of bedrooms plus 1 times 7.5 plus 1% of your floor area. In the Washington Mechanical Code, you're actually effectively having to increase your ventilation rate if the system is not balanced or not distributed. I'm sorry, if it's, yeah, exactly, not balanced, not distributed, and if it's intermittent. So these are taking some of the requirements from ASHRAE 2019 and basically incorporating them into the code, because they're realizing that if your fresh air is not distributed and it's intermittent, then it's not going to as effectively maintain quality indoor air. Now, how effective is ventilation? There's not a ton of research out there showing that whole house mechanical ventilation is effective, but there is some, and there's a great Building America research project that is wrapping up, and this report will soon be published. But in some of the preliminary findings, and in the Pacific Northwest, this was led by the PNNL. They looked at 138 homes that had mechanical ventilation that were built above code within the last 10 years or so, and 13 of those had heat recovery ventilation systems. Of those 13, 92% were operational as found. Now, that is substantially higher than exhaust-only systems and central fresh air systems that incorporate a supply into your central heating and cooling system. Those systems were much more likely to be non-operational, either from the get-go when installed or turned off by homeowners for comfort issues or just for energy savings, because they didn't understand the importance of the fresh air there. And the other finding in the study was that homeowners with an HRV or ERV were the most likely to be aware of their whole home mechanical ventilation system. And that makes sense. Instead of just a bath fan or a furnace with a fresh air duct coming to it, there's actually a unit, a box that is essentially the lungs for the house. And I think this speaks to the marketability of this technology, and that homeowners and home buyers are able to understand that type of concept and will value it. Here you can see some of the results from their study and the ventilation impact on indoor air quality. I'm excited when they have the full results published here in the next couple months, and that will even parse out some of these findings based on ventilation types. So we'll be able to see exhaust rates, exhaust mechanical ventilation compared to heat recovery or balanced ventilation, and see which ones are most effective at reducing your PM 2.5, which are some very, very small particles that we're realizing have some of the largest impact on respiratory issues, and also CO2. And again, there's a lot of studies out there that show the effect of CO2 and the air and its impact on our ability to make decisions and even our moods. So what we're seeing here is that with your mechanical ventilation on and running at least 80% of the ASHRAE flow rate, then you're getting better ventilation. So guess what? It works. And if you want some help here, as far as designing, Better Built Northwest recently put out this design guide for heat recovery ventilation systems. And this is an excellent resource. I highly recommend it. There's a link available here in the slide as well. So we're going to talk about the good, better, best spectrum of heat recovery ventilation. And on your good, you've got some spot ERVs. These are, typically a lower cost, especially with the Panasonic spot ERV. There are some downsides that we're going to talk about that for that unit. It's not the most efficient. It's about 67% sensible recovery rate. It doesn't have the highest airflows, maxes out at about 40 CFM. And at that point, it is fairly audible in terms of the noise. The Lunos ductless ERV on the right is a really excellent solution for the right type of scenario. Those operate in pairs across the room, and they'll intermittently operate, taking turns and 70-second intervals, either exhausting or supplying. And those Lunos units have a ceramic core that is able to transfer the heat energy. They are more efficient than the Panasonics, but in terms of the price range, especially if you're considering a price per CFM or dollar per CFM, the Lunos are up there really at the top with your highest end ducted systems. They max out at 20 CFM for a pair. With the spot ERVs, especially this Panasonic, this is the most common by far ERV that we see, or any heat recovery ventilation unit that we see installed. And again, the reason there is because it's a non-ducted unit, so you don't get distributed fresh air, it's localized. And you see on the left here, this is from the installation manual for this Panasonic spot ERV. Because of that sensible recovery rate that is not that high, again, this is a pretty small unit, and that recovery efficiency rate is related to the size of your heat exchange core and how much time that airflow is able to spend time in that heat exchange core where it's exchanging the heat between the airflows. So what you see in this map is in most of the US, zone B and C there, this unit is not recommended to be installed through the wintertime. So not the best option for fresh air if you can't run it for 5 or 6 months out of the year. Another consideration, a lot of times folks want to exhaust a bath fan. This is not a good idea with the spot ERV because of that moisture transfer to the incoming air. And the other downside of these, again, is their lower flow rates, maxing at 40 CFM. And at that point, they're not balanced. They are 40 CFM exhaust, 35 CFM supply. And the other issue is locating them. The installation location really matters. Now you can see in that photo on the right, this unit is installed high up on a wall. This is an ideal installation for the unit because if you look close at that photo, in the top left corner of the grill, you'll see a little triangle. Now what that is that's the supply air, and it's focused in that little area with a high velocity. So it can shoot that fresh air far into a room and not be mixing and essentially short circuiting with the exhaust air going out. Now, one of the biggest impacts on comfort is not only your temperature, your humidity, but your air velocity. So what you've got there is air that is tempered, but closer to outdoor temperature than indoor temperature coming in at a high velocity. So that can create comfort issues if it's shooting directly at somebody. So if you install it high on a wall like this, then that airstream is going to fly above folks' heads and mix, and then you're not going to have the same type of comfort issues. Another approach is to install this high up on a wall where you've got a central heating system and the return located maybe 5 to 10 feet away from that wall on the ceiling. So you're shooting that fresh air where it can then go into the return and be distributed into the home. So it is one way to extend the range of the spot ERV and overcome that issue of distribution to some extent. As far as better, the approach that is a step up from your your spot ERV systems are a ducted HRV or ERV with a simplified design. And this is what I highly recommend for builders who are just trying to get started with this technology, because if you try to go too far too quick without having the trade partners on board, then you can get essentially, as I mentioned, a ventilation system that's cost a lot, but is only going to work about as effectively as a couple exhaust fans. So with this simplified design, and this we're looking at a multifamily project built by Walsh Construction out in Beaverton, Oregon. They've got the units installed in a closet ceiling, so inside conditioned space. The ducting is very basic. There is a single return to the bathroom, and that is in lieu of a bathroom vent fan. This unit is set to operate continuously at about 50 or 60 CFM, depending on the size of the unit. And that meets the requirements for your spot ventilation for your bathroom at 20 CFM continuous. So this is a great way to value engineer your heat recovery ventilation systems in by reducing some of your other costs, such as for the bath fan. Now you can see that this is a ERV unit installed, and the way that I can tell is there's no drain. Typically a HRV is going to have a drain coming off because it does not transfer the moisture to the indoor airstream, to the incoming airstream, the same way that an ERV does, transfer some of that moisture. So the trick here is if you're going to use an ERV for your bathroom exhaust, that should not be intermittent. That should be running continuous. The reason being, some of that moisture from the bathroom after a shower can get on the heat exchange core, and if it then turns off, then you've got potentially damp dust that might build up there on your heat exchange core, and that is a recipe for growing mold and similar. So you want to just make sure that that's operating continuously. The other benefit here is register high on the walls. And again, registers high on your walls for supply to get your mixing up above the occupied area of the room. This is another example of a simplified design. And again, the unit's installed in a closet at the ceiling, a single return from the toilet, and a single trunk and branch supply system to just 3 supplies, very basic, simple ducting. And on the best level, you get the dedicated systems. And you want to look for equipment that's less than 2 CFM per watt. You want to look for a sensible recovery efficiency, SRE, that's greater than 80%. One trick there is you can look into some of the specifications on these units, and we'll show you a little bit of that in the HVI directory here, where you can find those specs. But also, once you dig into the specifications in an individual unit, you'll see the recovery efficiency ratings at different airflows. And when you get a HRV that you can turn down the airflow on, what you'll see is that recovery, that sensible recovery efficiency, increases at lower speeds. So one way to get a better unit is to get a unit that's slightly larger than what you'll need, and then run it at a lower speed. Dedicated distribution lines you'll see here. This is the 4-inch sonotube ducting that Alex will discuss some here soon. And the reason being, for the reason for dedicated distribution systems is these ducts are sized much better for the airflows that you're seeing in these ventilation systems. And so your heating ducts are typically much larger than what you would use in a dedicated ventilation system. You're exhausting from bathrooms and kitchens, and providing fresh air throughout the home. For support for those in Energy Trust of Oregon territory and Southwest Washington, feel free to reach out to the experts at Energy Trust, Dan Wildenhouse and Sean Hassel, and they will lend their expertise to your design. Coming soon, there's a verifier training on commissioning different systems, so you can also work with your new home verifier and to make sure that you're getting a quality install on your systems. And now I'd like to ask Alex some questions and introduce Alex's expertise. As I mentioned, Alex has designed, installed, and done the commissioning on dozens of heat recovery ventilation systems in the Northwest, and consistently has some of the highest performing installs that I see in all the high performance home builders that we work with. And so I'm excited to pick Alex's brain a little bit here with you all, and talk about some of the processes that have led them to where they are. So thank you so much for joining us today, Alex.
You're welcome.
Yeah, and so initially, when I started working with you guys back in 2013 or 2014, I remember you were contracting out your HRV installations on projects, but you've moved to installing them in-house. So I'm curious, what were the issues that you were having with those contracted installations that led you to bringing it in-house?
Yeah, I mean, that's a great question, because really what happened to us is as we're increased the performance of our buildings, like we're increasing air tightness for energy efficiency, we really quickly realized how important ventilation is. And at that point, really, ventilation was for most contractors still an afterthought, right? So the focus still was on heating and cooling. And then, there's the bath fan, right? And so we realized that ventilation in this whole house concept, as we were approaching it, was really kind of not in the most contractors' day-to-day bread and butter, and they had difficulties with equipment selections or design, or sometimes even pricing these units to understand what does it take. Let alone that on the worst end is that the quality of the install was not what we needed for those systems, right? And so we really decided then we more out of necessity, okay, can we bring that in house? And since we're not dealing with refrigerants or anything like that, it was a little bit of a stretch, but it was the step we decided to take and still do to a degree today.
So I'm sure that that was a process, right? I'm curious, what were some of the challenges you overcame, or lessons, so to speak, on the learning curve as you started installing the systems yourselves? And part two of that is what would you recommend to the average builder or designer who still needs to contract it out because doesn't have the capacity or the budget or margins potentially to be able to bring that type of installation in-house?
If you really look back, you did an excellent intro into the topic, and many people might even be familiar with some of the issues, but there's space constraints, where do we put the device, right? It's a new, okay, we maybe have a spot for a furnace or a heat pump, but now where do we put the ventilation equipment? There's different rules that apply. Or you need a condensate drain. Now you found a spot, how do I get my condensate drained away? And am I getting this in a fashion install that I'm, can reliably drain the system at all times and don't have a callback later because something got clogged? Ventilation rates obviously are, this is one of the key differences, I think, why some HVAC contractors took a moment to really adopt this idea is we're dealing with much lower flow rates, right? So now it becomes much more sensitive to duct lengths and how many fittings you use. And, so you really want to pay a little bit more attention to, initially to conceive the design and really make sure that you get to the point where you have the install becomes kind of an autopilot and you don't run into things that you have to later consider and that might throw off your entire design. You show a great slide there about the steps that we are really now taking, and really the more we emphasize the beginning, the early steps on this 4-step scale, the much more successful our installation will be, which obviously then also takes has a result into how much does it actually cost to install the unit. So the more care we do in the beginning when we're doing the planning, really identifying what do we need to do with ventilation rates. And you talked about supply ventilation, but if you have a dedicated system like we typically do, we return our exhaust from the bathrooms and the kitchen. We want to make sure we really need to get our exhaust rates there, right? We don't want to underventilate those spaces and have issues later. So that's really important. So can we, with our duct runs, we're saying, can we actually perform that? Once we know how much we address it, we have those flow rates established, then we can go to equipment selection.
Great. Yeah, and this one is an example of the planning and design from one of your recent projects.
Yeah, exactly. So we actually adopted this might be not everybody's process, but we're even for smaller projects, we now have mechanical drawings, just because it is still such a new aspect. It's just having the fact look, we're paying attention to this. It's important to us. And coordinating with other trades, so we don't get in the way with the heating and cooling system or the plumber. We really followed that philosophy, okay, let's put it on the drawings, let's put Snowden in there, because no matter who's on site, someone will look at the drawings and we make sure that we be successful with our designs.
Sure. That's excellent. So what does a typical system that you're now installing on a home look like?
Yeah, I mean, we had an image, we had an image earlier. Like, so we do whole house systems, dedicated, so dedicated supply and return, and like we were indicating earlier, we're saying like we're returning from the bathrooms and the kitchen because that's where our contaminants are, and supplying to the bedrooms and living rooms, right? And so that's what we're mentioned earlier. That's kind of cascade ventilation. So we have now. Supply and return on two ends of the home, so to speak. And this really allows us to transfer the fresh air through the entire home, no matter where you are. And we find like that really once you hit a certain performance level of home, really kind of this, like I was saying, the script flips a little bit, and ventilation becomes our main HVAC service, right? So really the ventilation is the like before we said like, okay, we had heating and cooling, and the ventilation was the afterthought. We really like flipped this and said like, okay, our homes are so important, so performing so well that we're saying, okay, let's look at ventilation first and make that a great system, and then heating and cooling really becomes the secondary service because our loads are so small.
Wow, yeah, that's excellent. So as far as the design on your systems, are you designing to this 2010 flow rate, or how do you design your systems?
So, that was interesting when I saw the Oregon code come out, because, like the 2010 indicates that's a standard from 2010. So it's a little older. And I was surprised because I do feel like we design ours to the current standard. So ASHRAE 62 to 2019. It's a higher flow rate. And we really find that's important, right? And so the beauty is here that with the heat recovery, we actually have the capacity, like we don't get an energy efficiency penalty, like an energy penalty, if we would increase ventilation without heat recovery, right? The more we ventilate without heat recovery, now we're exhausting, our precious conditioned air, which we're actually trying to, the energy we're trying to conserve. But with heat recovery now, we can up our flow rates, which really has an impact on indoor air quality. So we typically design more similar to what ASHRAE 2019 is. The other rule of thumb, I think, is like when you do some of these calculations, and you can see here, right, we're really on certain homes that's over twice the ventilation rate. Another rule of thumb is like we want to exchange the entire volume of the house every 3 hours. Mm-hmm. So a third of an heat exchange, air exchange per hour is kind of another great rule of thumb. But yes, I think in general, and we all encountered, these events we're having. I think ventilation rates, even these might still be a little low, and we still would want to increase ventilation rate because it has such a big impact on the indoor quality and the comfort and health of the occupants.
Yeah, one of the a couple of the traits that I've noticed on your installs are the boost switch that's always available, and on the most recent project, the pre-filtration box that you said was in response to some of these wildfire events that we've experienced here regionally.
I mean, this is a great topic because traditionally, like outside air is always a better quality, in most cases than indoor air, right? Indoors, we cook, we shower, we have off-gassing from furnishings and materials, right? So typically we're saying like, hey, as long as we're bringing outside air in and diluting inside air, we improve our air quality. Well, there's one moment in time where that is not true anymore. It's with these severe wildfires, right? So now, like, okay, what do we address? And I think we've been talking about this a lot of times. And so we're just saying like, okay, we want to keep the benefit of the outside air. So we're just basically adding additional filtration to the unit to make sure that the air quality remains high, even if we bring outside air in. But if that's not an option, then it's important to instruct your owners, your homeowners and your occupants about how to operate the system. And that's a key point that we're, probably getting to in a little bit too, that the homeowner education is super critical on the success of these systems. But yeah, so that if you don't have, superb filtration, then we probably want to turn the unit off during these wildfire events because, we're not getting the benefit that we want. But that's the alternative, is just to improve ventilation. And the boost switch, we're talking about continuous ventilation, which is always preferable to intermittent, I think, even in bathrooms, because we really have continuous exhaust, even, like the humidity that remains in the towels and in the tub or shower that evaporates later would still be evacuated. But the boost switch is really kind of like, what that means is we up the ventilation rate even a little bit more. It's kind of, I call it a convenience boost, so that if you have a steamed up bathroom, you can increase the flow rate for a certain amount of time to clear that out a little quicker.
Mm-hmm. That's great. So how did you decide on your standard equipment selection?
Yeah, so, it's all about the efficiency. I mean, there's that's definitely where you should start, right? You need to, what we need to understand is, yes, we ventilate, and the valid question that we hear from owners. Well, now we're introducing, another energy use, right? So we have fans that we're moving air around. Like, why should I not open just the window? And we talked about the benefits, right? We get better distribution, we get maybe filtration, and then we get heat recovery. So now it's important, what is that level of heat recovery, so that we're actually recovering enough energy to offset this additional fan use. So that's why I think it's important to look for units that are 80% or better, because otherwise we could recover some energy, but really we kind of offset that, or worse, with the fan energy that we introduced into the system. So I think looking for 80% or better, and like really finding systems that are, efficient. The nice thing is, like, as you have on the screen right now, we have resources where we can compare ventilation units. So definitely talk to your preferred trade partner about what their preferred vendors are or systems. I'm a big fan of like working with our trade partners and like, hey, what are you used to? Like, what's the equipment or the installs that you're used to, so that we don't need to reinvent everything and make it more complicated or difficult that can, have like later consequences in the quality of the install or the price, So work with your trade partner, like, hey, what do you have brands you prefer? And then like, look together and like, hey, what are the performance specs? Definitely look at the specs so that you understand what you're getting.
Yeah, that's great. So how important is the commissioning aspect of these systems, and what support do your different trade partners provide there?
Yeah, so that is really kind of, I think, where some of the, like the biggest learning curve is, because, which many people already understand probably from heating and cooling, commissioning is important, but it's not always done, right? And that's when we, on the heating and cooling side, we get like cold spots, like certain spaces are underserved. So commissioning is really always an important step. And I think for ventilation, even more so, because it is a new system, right? So not only for probably the contractor, or the trade partner who might be just like getting into whole house ventilation, but also the occupant, right? So that how are they operating this? So, and we're talking about these little flow rates that if they're off by a lot immediately, right? So commissioning really is critical for success. You mentioned some other items. If like we have an intermittent exhaust from a bathroom, we might even get mold issues, right? So make sure, just like we're talking in the beginning, look at the equipment and how it performs or supposed to perform, so you know what you're getting. At the end, make sure that someone checks the system is actually doing what you want it to do, because you invested a lot of money. There's huge benefits. So let's make sure that it actually does what we hope it, or what it can do.
Sure, absolutely. Oh, can you speak to some of the benefits homeowners are getting?
Yeah. So specifically, I think, we all understand why ventilation is important. We tighten our homes up to make them more energy efficient, right? So it's important to bring in fresh air. But so specifically, with an HRV, we touched on this some, but it's a nice summary here that because we're recovering our heat, we can now increase our flow rates, which means we have better indoor air quality, which is important. Like our homeowners, I don't know if people seen more and more sensors pop up. People that can be affordable. People can actually get feedback. Homeowners say like, hey, my CO2 levels are high or something like that. Like, what's going on? Our occupants are informed. They want these systems. So with higher flow rates, they're going to be happier in their homes, and also going to be a good recommendation. Same with the comfort, right? So now we're understanding if we bring in air without heat recovery, it means we're bringing air at outside conditions. So if it's cold outside, we're bringing in cold air. If it's hot outside, we're bringing in hot air. So that can increase, even if you have low flow rates, that can really have, result in some comfort issues, like you were referring to with some of the lower performing units or without heat recovery. And that makes a huge difference. Like comfort is, if it's around HVAC, comfort is already so subjective. Everybody experiences it differently. Let's make sure that we can give them the most comfortable home that they can have. And then, the energy savings obviously are improved on these units as well. So yes, probably slightly more upfront cost, but really the continuing benefit for the lifetime of the equipment, and the duration the owners are there are day to day. So that's a tremendous effort. That's important to point out that yes, code requires us to do this for energy efficiency, some energy, some indoor air quality concerns too, but really the benefit the owner gets is so manifold that you really need to educate them about them, that they understand, like, okay, there's this piece of equipment really improves my lifestyle or my style of living.
Sure. Well, and I think that Building America study that we looked at earlier showed that, homeowners that have a heat recovery ventilation system are significantly more likely to be aware of that and those benefits that come with it. So I think you're absolutely right there. Now, you spoke about some of the challenges that you had. What recommendations or advice would you give to a builder who's trying to adopt this new technology for the first time?
Yeah, I mean, finding the right partner, like just really finding an HVAC contractor who like understands whole house ventilation, can talk to you about equipment selection and why, I think is just critical because, particularly right now, everybody is really busy. And if they're not familiar with what you're asking, they're probably not very interested to learn it right now. So find someone who like understands what you're getting at, wants to do it as well. Apologies. And can deliver what you need.
Sure. That's great. Now I wanted to bring up the Minutair. I've seen a couple of your projects. Do you want to give a little bit of tidbits about this one?
Yeah, so this is a really interesting unit, which is like, we've been talking about, or we touched on cost, right? We're saying now we have a heating and cooling system and we have a ventilation system, right? So there's two pieces of equipment, maybe even two distribution systems. That sounds expensive, right? And even though we can optimize that and improve that, we're dreaming up about it. Like, can we have a system that does it both, right? And so we're saying how, like, for us and our, the efficiency levels that we're providing, ventilation becomes the important one. So can we, rather than like some of the other approaches you might know, like, okay, we have a furnace and we put like fresh air into the furnace plenum and distribute it that way. This unit really takes the other approach, like we're ventilating first and we're also introducing some heating or cooling in the unit. So this is kind of this all-in-one. This is like, like before these systems arrived in the US, we were talking about the magic box that does it all for us, right? So heating, cooling, ventilation, filtration, dehumidification. And so this unit does that. And it's a really compact, like as you can see, it's probably around 4 feet wide. So it can fit in a, mechanical closet, right? If you take into account how you distribute your ducts. But these can be really cost effective, but the key piece is like their capacity is limited. So these only really work for small homes or like otherwise, really high performing low load homes, but they work well for us. And I think that's the step that we should be taking to really make this viable for everybody. It's like these combined system, as long as they deliver all the services appropriately.
Sure. Yeah, that's great. And my experience with them is you're absolutely right. They're a great system for those low load homes, and they don't have to be a small home. I mean, these can max out at 250 CFM, and we've tested them, and when they're set to run at that rate, they do run at that rate from our experience.
Yeah. So the capacity is around, it's a little over 8,000 BTUs, right? So there's what you see on the top left in the picture The box is like a post heater, so there's a resist, like just as a backup. So if you're thinking, like if people might be familiar with, we're designing like for the coldest day of the year, right? But that really doesn't occur that often. So we can use equipment like this with backup heat, because we're saying like, look, 80, 90, 95% of the time, it will be totally sufficient to use heat pump technology to provide heating and cooling. But if it's a little too cold, we have that backup heater. So that really extends the range that you can install these units dramatically. But yeah, people might be familiar. 8,000 BTUs is not that much. But yeah, like we heating homes 2,500 square feet and more, if the efficiency of the enclosure is appropriately.
Well, thanks so much, Alex. That was excellent. And just wanted to give some backstory here. This was one of the Green Hammer projects where we went out and tested our different commissioning equipment. And Alex had done the commissioning himself already with that piece of equipment behind him, which is extremely accurate, high-end testing device. So we were happy to get insights into how all these worked.
Yeah, I mean, that was, this is really kind of speaks to the collaboration that's necessary. It's like we're all trying to achieve the same goal. Like verifiers are here to help you. I just want to make a plug for Earth Advantage and the Energy Trust. They really can help you achieve the goal. They want to make sure it's done right, and that's really to protect us as a contractor. So this was really a fun exercise where we use different testing equipment to see like how different are they in accuracy, and how do they function differently for different systems. And that kind of education, I think, is really valuable for us as a contractor. And I really appreciated that everybody made the time to come out and look at our site.
Absolutely. No, we all learned a lot as well from that activity. So if you all want to learn more, there are opportunities.
Thanks again, everyone, for joining us. This On the Level series is part of the Sustainable Homes Professional course and one of the many, many contents that we offer. Go ahead and next slide. So we have been offering SHP and SHP credentials for really about the past 10 years to hundreds of professionals across the state who have attended this course, which has helped take their project to the next level. We are really happy to announce that this program is now offered online. So what used to be a 12-day spread over 6 months was a really hefty commitment, and also limited where we can offer it as well. So the SHP 15 hours of content really holds the same value as the in-person. With that is training videos, professionally filmed site tours, live webinars such as this one, speaker presentations, product development, and more. So anyone can access it from their location. And one of the contents that we do offer that is also the same is called Fill in the Gap, where you actually get live Q&A with the instructors themselves. Those are going to be airing again here in May. So definitely encourage everyone to get as far as you can in the current SHP program. Next slide. And also just to go over pricing, we do have discounts for affordable housing, also Earth Advantage professionals. We do also do group discounts for $50 off for 2 or more. So that's definitely something that you could take advantage of currently. The next slide.